Good morning, class. Today's lesson is 1.2 on segment addition postulate. Our goal is that you will be able to use segment addition to find the length of a part or the length of the whole segment. So first, our first vocab term of the day is postulate or axiom, and you're going to hear us talk a lot about postulates or axioms in geometry. And really, it is a rule that is accepted without proof, and it's something that we use to prove theorems later on. So the segment addition postulate is going to use a little bit different notation. Remember that we learned that this is how you notate segment addition, or this is how you notate a segment with the line above it. But when you talk just about the length of a line segment, you don't need to put the line above it. So it's just a little bit different. So this would be the length of the line segment AB. So here's our first segment addition postulate then. So think about this line, and if you're looking at the segment between A and C, and if B is between A and C, then you could say that if you added this length of A and B plus this length of A and C, it would give you the whole, or B and C, it would give you the whole length A and C. So we would write that like this: AB, this piece, plus BC, this piece, is going to equal AC, the whole segment. And that makes sense. So let's look at a few examples. So we're going to use segment addition to find JL, which is the whole length here. So we know that JK is 8.4, and we know that KL is 3.9. So we could find the whole length by doing 8.4 plus 3.9, which would give us 12.3, and our units are centimeters. So I lined up the decimal points in order to add vertically there. Find the length of AB. So this time you are given the full length of AC, and then you're given the shorter length of BC, so you're looking for this distance right here. Well, if you have the whole length, you can either set up an equation like x plus 5.8 is going to be equal to 13.2, and then solve that way. Or thinking about it logically, you know the whole length, and you need to subtract off the part that you know. So lining up my decimals again, we're going to have to subtract and borrow, make that a 12, and we're going to get 4. 12 minus 5 is 7, so 7.4 centimeters would be the length of this piece right here. Because these two, and we could double check our math by adding these two together again, and then that should equal 13.2. Except for I didn't pay attention to my units this time. It was not in centimeters this time. It was in meters. So just M. If y is between x and z, and xz is 12 and xy is 5, find yz. So a diagram is always helpful in geometry. So let's draw something here. We got y is between x and z. So I'm going to put x, y, z. So y is between x and z. Now xz, so that's this full length, is equal to 12, and xy is equal to 5, then find yz. So that's the spot we're looking for there. So when we add together 5 plus that other piece, it should give us 12, and we know that 5 plus 7 is 12. So our length for YZ is going to equal to 7. And there are no units in this one, so you could just write units like that. Okay, so in this one, we're going to use our algebra skills to help us find the value of x. So we're going to use segment addition postulate because we know that the full length of this segment is 30, and then we have these two partial lengths. So we know that the length of segment NL plus the length of segment LM will equal the length of segment NM. So that means if we substitute in what we know, the distance of NL is 6x minus 5 plus LM, which is 2x plus 3, which is equal to 30. Now the parentheses weren't necessary per se because we have just one group of each, and so we can add like terms from here. So 6x plus 2x will give you 8x, and negative 5 plus 3 will be negative 2. And then you need to use your algebra skills and your inverse operations. So you want to isolate the x to solve for it. So that means you first have to get rid of any addition or subtraction. So we're going to start by adding 2 to both sides because that's the inverse of minus 2. Because negative 2 plus 2 gives you 0, and you're left with 8x on this side. 30 plus 2 is 32. Then 8x, remember that means 8 times x, anytime you have a number in front of a variable like that. And the inverse of multiplication is division, so we're going to divide both sides by 8, because 8 divided by 8 gives you 1, and 1x is just x, that implied coefficient, and 32 divided by 8 is 4. So x equals 4. And this problem was just asking me to find the value of x, but you could now go back and find the value or the length of each of these segments using that x. So 6 times 4 minus 5, substituting back in the 4 for the x spot. 6 times 4 is 24 minus 5, this would be 19. And then 2 times 4 is 8. Plus 3 is 11, and notice that 11 plus 19 does give you 30. So those are our individual segment lengths if we needed that information as well. Now let's find the value of x given that we know that US is equal, find the value of x and US given that UT equals 12. So we got to read that more carefully. So UT is equal to 12, and they're asking us to find the full length after we find that. So right now we have that this 5x minus 3 is equal to 12. So we'll use that information to figure out first what our value of x represents. So using my inverse operations again, we're going to add 3 to both sides. And we're going to have 5x equals 15. 5x means 5 times, so we're going to divide on both sides. We're going to get x equals 3. So we know that that side was 12, and we could plug 3 back in to just make sure. 5 times 3 is 15, minus 3 is 12. So then 7 times 3 is 21. And then if we add 12 plus 21, you're going to get 33 for the total length of US. Okay, one more. Suppose O is between points M and N. Let's draw that diagram first. So we got M and O and N. So O is between M and N. Use the following information to solve for the value. So MN, which would be the total distance, is equal to 4x plus 10. MO, which is right here, is equal to x plus 5. And NO, which is the same thing as ON, is 2x plus 15. So we will have to add these two pieces and set it equal to this piece in order to solve for x in this case. So that's going to look like this: x plus 5 plus 2x plus 15 is going to equal 4x plus 10. To solve this, first I have x's on the left side together, so I'm going to combine my like terms. Remember, it's implied if I have an x, that's a 1x. 1x plus 2x is 3x. And then 5 plus 15 is 20. And we have 3x plus 20 equals 4x plus 10. Now, when you're left with variables on the both sides, you have to get all your x's to one side and all your constants to the other. I have more x's on this side, so I'm going to move these x's over here. And you're going to do that with inverse operations. This is a positive 3x. So to get rid of it on the left, you're going to do minus 3x. And you're going to line that up with the like terms, which would be the x term. So on this side, you're going to have 20 left over because 3x minus 3x is 0. 4x minus 3x is 1x, and you still have a plus 10. Because I moved the x's to the right, I need to move that 10 to the other side. The inverse of adding 10 is subtracting 10. So 20 minus 10 is 10. 10 minus 10 is 0, so we're just left with 1x, which is the same thing as just x. So we got 10 equals x, or our final answer is x equals 10. Now if we put 10 back into each one, 4 times 10 is 40, plus 10 more would be 50 for the length of mn. So that's the whole length. And then in MO would be 10 plus 5, which is a length of 15. And in OM, it'd be 2 10s, which is 20, plus 15, which would be 35. So this length was 15, and this length was 35, and the total length was 50. So then we have finished the full question. So in summary, you can have, if you have a segment A, we'll just do ABC, remember that the length of AB plus the length of BC is equal to the full length of AC. And you can use that in many different ways to solve these problems. Thanks for watching.